Stephanie, hi.
Hello.
Could you tell us a bit about your company and your role within it?
Sure. So I'm Stephanie King. I'm Senior Physicist at 3Sci Limited. 3Sci has a strong heritage in the oil and gas industry actually, and we've got a lot of our corrosion sensing products installed around the world. But we've also got a strong basis in research and development, which is where projects such as the FIP Challenge come in. And it's been enabled us to have the freedom to explore a brand new technology, which we're excited about. I think it's going to underpin a new family of sensors for 3Sci. And as senior physicist, it's been a real career highlight. I felt really lucky to lead the development of a brand new temperature sensor that can withstand the extremes of fusion. So my role has involved tasks such as initial ideas and concept analysis, running modelling and test programs to validate those ideas, and then finally building and optimising prototype designs for final testing with the view to then larger scale manufacture for first generation product to launch.
Could you tell us more about the project specifically that we funded under FIP?
Yes, so the main FIP challenge that we worked on was looking at new sensing technologies for fusion environments. And a real achievement for 3Sci under the FIP challenge has been to develop this new generation of products that we have called ExtremSense. Now, ExtremSense we think is a world first. It's based on electromagnetic principles, hence the N in ExtremSense.
Okay.
And it can be made from a purely metallic structure, which means we can make it from fusion grade metals as they come into development, and then we can get as close as we like to the front wall for monitoring temperatures in critical plasma facing components. Depending on the material that you select to make ExtremSense from, we could measure up to 3,000 degrees or beyond. We've got sub-degree C resolution on our temperature measurements, and we've got inherent neutron resilience because of the fusion grade metals that we're choosing to manufacture from. Combined with that, we've realised that our technique is really versatile, so we've actually got some recent FIP funding for exploring a magnetic field sensing version of our device. So this is where the family of products starts to come in, and the magnetic field sensing version will still benefit from all the attributes of ExtremSense, so high temperature resilience, high radiation resilience, but the aim of this one is to aid plasma control. So we see the FIP challenge has enabled us to develop this family of sensors that's really versatile, and we see it as really unique and innovative, and we're really excited about where it might take us in the future.
It's so good to hear the progress that you've made, because I think people hear the extreme environments of fusion and they think, well, how can you possibly solve that? But here you are with solutions to these very extreme conditions, as you say, this new generation of sensors.
And I think sometimes with science, is as with everything, it's about breaking it down. You can't solve it all in one go. It's about breaking it down into manageable steps, which I think we've been able to do along the way.
Brilliant. And what's the next step for you and your company?
So the next steps for 3Sci and ExtremSense, the first one to take is to capitalise on some of the commercial interest that we've been able to generate under this project phase that's been funded through FIP. For example, we've got an opportunity to have a field trial in Malaysia on some rare earth processing equipment, where they have a requirement to measure temperatures online up to 1,200 degrees. So we're in the process of scoping our sensors for that, so that we can support that field trial, but it'll be a great way of putting it through its paces. Meanwhile, we're enjoying the technical challenges of developing the magnetic sensor variant, and progress is going well on that. For both ExtremSense, temperature and magnetic, we're keeping in touch with the fusion community, liaising with them, communicating our successes and progress, because we'd love to take it to the next step of fusion development and get access to test rigs and facilities to grow it in that market as well. And we've really got our sights set on a global uptake of our product on fusion power plants worldwide, and especially exciting projects close to home such as STEP as well.
That's fantastic. Thank you so much for sharing your progress with us today.
It's been great.
And watch out for more videos from the FIP Showcase event.